So if x is none, we initialize both x and y to the starting position s. Then we assign start x and start y to the variables x and y. What can we do next? We need to check if our position is a valid position that we can go through. What, ultimately, is a valid position? Only start and any cell along any valid path. Therefore, we can say that if the cell corresponding to x and y is the starting cell, or a cell along some path within the maze, then we can continue our search. So with this construct, we can see whether the value of the cell is within values path and start. If so, then we mark the cell as visited. Because it doesn't make any sense to visit the same cell twice, so let's mark the cell at current values of x and y as a visited cell. After this, we need to try to move in other directions. How many directions do we have? 4, of course. We can move north, south, east, or west from the position of our current cell. So let's call solve recursively. By moving to the right, hence with x plus 1, but with the same y value. Or moving to the left with x minus 1, but the same y value. Then we move north by increasing y, but keeping the same x value. Or actually, we're moving south this way because we're going down. Lastly, we move north, keeping the same x and decreasing y by 1. As it often happens with recursive methods, it's a kind of magic. We trust them in what they do. If this recursive method will return value true, then the current cell will be part of the solution to the maze. We just need to know if any of our explorative paths toward north, south, east, or west will bring us to a solution. Then the current cell is part of the solution. And we can return to ourselves. But if the cell is neither start nor path, but it is the exit cell, then the current cell is the final one. So we can also say, in this case, method solve returns true. Moreover, because it's arrived to the exit cell, it will return value true. If none of these conditions is true, so if we find ourselves contemplating a wall, solve should return false. We're actually done. It seems incredible, but with just a few lines of Python code, we're able to solve a maze. So let's test the result of method solve. And if it returns true to the caller, then we print the maze, confident that we've found a solution. Our method has found the exit. It has tried to explore the maze a bit, then it found a blind alley, it backtracked, and finally it got fed up with messing around and it arrived straight to the final cell. The solve method may seem magic, but in reality it's very simple. It doesn't do anything else except try every alternative without going through the same path twice, keeping track of where it's been previously once it's arrived at the end. At a first glance, this maze may look too simple, so let's introduce more complexity. Let's change our program so that it's capable of reading the maze from an external file. We'll use the module sys, which permits us to load in a single variable every string passed in on the command line. So if our program is called with an argument, we take for granted that this argument is a file name, and then we read it, reinitializing the maze with the content of the file. We don't perform any check for the existence of the file because this is a demonstrative program at best. If we don't get any variable on the command line, we use the value with the simple maze as the initialization string for our program. To test the program more thoroughly, I've used Google and I've searched for files using the search terms ASCII maze. I found one a bit more complicated than our simple one, this one. Let's open a terminal window. Let's try to run the program without any argument on the command line. And now let's try with maze1. That's the file we just saw. The solution is a bit more complicated than our initial example. I've downloaded 3 more files which are much more complex. I'm going to show them to you. This is really long. Let's resize the window because of line wrapping. This is even more complex. And lastly, this one it's huge. I think that it's impossible to solve it manually. This maze is so fast that it will probably throw an exception. In fact, our recursive method will call itself for every single step that will bring us to a solution. So if the solution is composed by a path so long, the recursive method may run into Python's default limits. Let's see the solution of the second maze. No problem. But let's try now to execute the maze solver on the third maze, maze 3. Once again, no problem. Here Python has explored a good part of the maze before arriving to a solution. So even in this case, finding the right path has not been simple. Let's give a shot at the biggest maze now. As expected, we get an exception because we've reached the maximum limit of recursive calls. But don't panic, let's increase it. We can even do it with a simple method call. 10,000 is a value that should be more than adequate for our program. Let's run it again with the most complicated maze. But first, it's better if we change the font used by the terminal, because probably we won't see the solution with such a big font. So let's reduce it. Let's see if Python can find a solution. Yes, it's explored most of it. The solution is quite complicated, a nice zigzag before getting to the exit. It was quite fast too, but let's try to measure the time that it took to find a solution for this humongous maze. The command time on Unix can give us a hand. It took 1/10 of a second to find a solution for this maze. That personally, I'm not sure I would have been able to solve in an acceptable time. I really hope that I've been able, with these few lines of code in Python, to familiarize you with the elegance and power of this language. If I haven't succeeded, then shame on me. It's entirely my fault, not demonstrating Python in a suitable manner. But I hope that's not the case, and that you'd like to give this fantastic language a chance. I read a saying once, choose work that you like, and you'll not even work a single day in your life. With Python, you'd be very close to that. Ciao.